Hey guys, hope you're doing well. So today we'll talk about sum and difference identities for trigonometric functions. Before we start, I hope you heard from your friends in 12th grade that last year they were allowed to have a note card. This is a note card where you write a bunch of formulas. There's going to be a bunch of formulas that we use in this unit and forthcoming portions of this unit and other units. This unit. You'll be allowed to write only trig identities and formulas, and this is going to mean the same thing. So just write identities and formulas on the note card. You can use it on quizzes and tests for this unit if it meets conditions 1 and 2. So these are some of the formulas or identities that you're allowed to write on your note card. This one is from the from the Pythagorean identities. The first one is sine squared theta plus cosine squared theta is equal to 1. You can, I'll give you cardboard papers in class tomorrow. Yeah, whenever. You can write these formulas on them. So since sine squared theta plus cos squared theta is equal to 1, then if I decide to take, if I subtract cosine squared on both sides, subtract cosine squared on both sides, then what I get is the second identity, or the second formula. Or from the very first one still, if instead of subtracting cosine squared, if I subtract sine squared, first erase this. If I subtract sine squared on both sides, sine squared theta, subtract sine squared theta, then what I get is the third formula. So you can write those on your note card. Still from the first one, and I hope you remember this, I talked about this in the last video. Oh, we talked about this in the last class period. If I divide by sine squared here, if I divide by cosine squared, each term in this equation, if I divide it by cosine squared, I get what I have over there. But because sine squared over cosine squared is tan squared theta, cosine squared over cosine squared is 1, and 1 over cosine squared theta is just secant squared theta, which I have over here. So again, on this one, I can rearrange it how I want. I can say if I take the 1 the other side and the 1 turns into a negative, then the equation is going to be tan squared theta is equal to secant squared theta minus 1. You can also write it as 1 is equal to secant squared theta minus tan squared theta if you wanted to, because you have this 1 over here. Let's erase it. So from this one, if I take tan squared away from this side, and I take tan squared away from that side as well, right? Then I'll have only 1 left on this side is equal to secant squared theta minus tan squared theta. So I can express these identities or formulas however I want, and how I express them can help me solve problems according to what I'm interested in. I told you about this yesterday. So from the first Pythagorean identity, again, this one here, from this one here, if I choose to divide by sine, if I divide this by sine squared theta, and if I also divide this by sine squared theta, and I divide the 1 by sine squared theta, then what I end up with is sine divided by sine gives me cotangent, gives me 1. 1 gives me 1, not cotangent. And cosine squared divided by sine squared gives me cotangent squared. And on this side, 1 divided by sine squared would give me cosecant squared theta. Cosecant squared theta. Cosecant squared theta. So I can rearrange this. If I want to take the 1 that side, that's by subtracting 1 from both sides. I'm sorry about this handwriting. Cosecant CSC squared theta. If I want to take away the 1, subtract 1, then I'd have This basically is the same thing as this. I can read it before I started talking. So this is cosecant squared theta. This is asking me what cosecant is equal to. Well, that's equal to the same thing as this. That's just cotangent squared theta plus 1. This is asking me what cotangent is equal to. Well, it will be cosecant minus 1. So on your note card, you can write really small things because there's going to be a lot of formulas that will add to the note card, and you only get to use that one note card for the rest of the unit. So some things about these identities or formulas. This is just like to the algebra, sorry. Whatever you can do to an algebraic equation, you can also do to a trig equation. So from this equation, I can see that this is a difference of squares. So this will become x minus 2, because 2 squared is 4. This 4 is basically the same thing as 2 squared. So it's the same as x minus 2 into x plus 2. And I also see a difference of squares here. Just think of this as your x and think of this as your 2. So then that's going to be tan theta minus secant theta, close brackets, open brackets, tan theta plus secant theta. So whatever you can do to an algebraic equation, it also applies to trig equation. And a lot of this work that we're doing in this unit is going to be calling on your knowledge of algebra and simplifying expressions. A bunch of it is going to be also requiring you to work without a calculator, and you might be wondering, why am I doing that? Well, the early mathematicians who discovered these ideas, who discovered these relationships, didn't have calculators to do them. And I know you're saying you have calculators now, but it helps you to understand the thinking processes behind these functions, behind these formulas, if you want to apply them further. And if that's not the purpose you're doing it, then it definitely helps sharpen your brain. So yeah, thank those guys. So if I want, I can add 3 to the side, and I can also add 3 to the side. Going on about the idea of something happening to both types of equations. So then I'll end up with x squared is equal to 8. And on this side, I can decide to subtract or add. Sorry, subtract. I can decide to subtract 1 and subtract 1, then end up with tan squared theta is equal to secant squared theta minus 1. And I can do anything I want. If I want to multiply this by 4, both sides, right? Multiply both sides by 4. I can do the same thing here. Multiply both sides by 4. So I'll end up with 4x squared equals 4 times 8. Oops, this is 4 times 8, which is 4 times 8 is 24. Ha! It's not 24. It's 32. 32. What am I doing? 32. Okay, that was the information. So I can do anything to an algebraic equation. Just the same way I deal with algebraic equations is the same way that you deal with any kind of equation, honestly, in math, in physics, in chemistry, whatever. If it's an equation, the ideas or the operations are the same. You can multiply both sides by the same thing that you want, as long as you multiply it by the same thing. And remember, in this unit, you're going to be manipulating equations a lot so that you get to what you want. So, algebra. I know that you've noticed that I'm going slowly in this video. That is on purpose. You can speed it up if you want, but I want to make sure that I catch everything. Another example, if you have something like tan theta plus cotangent theta, and you want to make them squared, or if you want to turn it into a difference of squares, then you simply multiply it by its conjugate, right? So the conjugate of that expression, the conjugate of this expression would be tan of theta minus cotangent of theta, which, since is now written as a difference of squares, will just become tan squared theta minus cotangent squared theta. Pause. AirPods need to be recharged.